Your water utility is a subscription service with no cancel button, and the infrastructure delivering it is one grid failure, one contamination event, one billing crisis away from leaving you dry. Every month you pay, you're renting access to something your great-grandparents owned outright. Today, we're ending that rental agreement. 8 water systems that move, store, filter, and deliver water using zero electricity, zero monthly fees, and physics principles that have worked for thousands of years. This is infrastructure you own forever. Here's the real cost of municipal water. The average American household pays $1,100 per year for water and sewer service. And that number has increased 80% in the last decade, outpacing inflation by a factor of 3. But the bill is only the visible part of the tax. Factor in the infrastructure that fails. In 2021, the Texas grid collapse left millions without water for weeks. In 2014, the Flint crisis exposed what happens when aging pipes meet budget cuts and bureaucratic negligence. In 2023, over 7,500 boil water advisories were issued across the United States, meaning the system you're paying for couldn't guarantee you safe water. Here's what they don't tell you. The pipes delivering your water are, on average, 45 years old. The American Society of Civil Engineers gives U.S. water infrastructure a D+ rating. You are paying a monthly premium for a deteriorating asset you don't own and cannot repair. Meanwhile, the alternative has existed for millennia. Every system we're covering today operates on one of 3 forces: gravity, pressure differential, or kinetic energy from flowing water. No motors, no electricity, no service contracts. Once installed correctly, these systems work during hurricanes, grid blackouts, droughts, and they work for decades. Your great-grandparents didn't have a utility bill. They had infrastructure. There's a difference. Infrastructure is an asset. A utility bill is a liability. We're going to walk through 8 specific systems, where to source them, what they cost, how to install them, and how long they last. By the end of this video, you'll have a complete blueprint for water independence. Number 1, the hydraulic ram pump. The hydraulic ram pump is the most underestimated piece of water infrastructure on Earth. It uses the kinetic energy of flowing water to pump a fraction of that water uphill, with no external power source. None. The physics. A large volume of water falls through a drive pipe, builds momentum, then slams a waste valve shut. That pressure surge, called a water hammer, forces a smaller volume of water through a delivery valve and up an output pipe, sometimes hundreds of feet uphill. The pump resets and cycles again, continuously, indefinitely. These were manufactured commercially in the 1800s and powered farms, estates, and entire villages across Europe and America. During World War II, isolated British farms used ram pumps to maintain water supply when electricity was rationed. There are documented installations still running after 50 years with no mechanical service. What you need: a water source with at least 18 inches of vertical drop, a stream, creek, or spring. Drive pipe length should be at least 5 times the fall height. A basic 2-inch ram pump from a manufacturer like Cloudburst or Rife Rams costs $300 to $600 and can deliver 1,000 to 3,000 gallons per day uphill to your home or storage tank. Installation requires no special skills: copper pipe, basic fittings, a concrete anchor pad. Maintenance is annual valve inspection. Here's what most people miss: a ram pump works 24 hours a day. It doesn't rest. A solar pump runs 6 to 8 hours. Your ram pump runs all 24. That continuous output fills tanks, feeds irrigation, and runs gravity distribution while you sleep. Number 2, the gravity-fed spring box. If you have a spring on your property, or within a reasonable distance, you're sitting on a permanent pressurized water source that requires no pump of any kind. The spring box is how you capture and protect it. The concept is simple: a concrete or stone collection chamber built around the spring's emergence point, sealed to exclude surface contamination, with an overflow pipe and a gravity-fed delivery line running to your home. Spring boxes have been the primary water source for rural Appalachian families for over 200 years. The technology predates America. Roman villa estates in the 1st century used spring capture systems nearly identical to what we build today. Properly constructed, a spring box provides clean, cold, naturally pressurized water year-round with zero operating cost. Construction cost for a basic concrete spring box runs $200 to $800 in materials. You'll need to identify your spring's gallons per minute output. Anything above 0.5 GPM is sufficient for a household. Line the collection chamber with concrete block or poured concrete, install a screen and overflow, and run food-grade polyethylene pipe downhill to your home. Elevation difference creates pressure. Every 2.31 feet of vertical drop equals 1 psi. A spring 50 feet above your house delivers over 20 psi. That's running water, real pressure, no pump, no electricity, no bill. Have your spring water tested annually. The USDA Cooperative Extension Service offers low-cost testing in most states. Add a UV filter inline if pathogens are present. But here's the advantage. Spring water is naturally filtered through bedrock and typically far cleaner than municipal water, which is chemically treated to compensate for system-wide contamination risk. Number 3, rainwater. Harvesting with gravity. Distribution rainfall is a free resource your roof is already intercepting, and most people route it straight into the ground. A properly designed rainwater harvesting system collects roof runoff, filters it through first flush diverters and sediment screens, stores it in elevated tanks, and distributes it via gravity to the house, the garden, or both. No pump. The storage elevation is the pump. Texas experienced such severe water stress in 2011 to 2012 that rural counties actively promoted rainwater harvesting as emergency water policy. Communities in rural India and sub-Saharan Africa have used rooftop collection for primary water supply for generations. A 1,500 square foot roof in a region with 30 inches of annual rainfall can collect over 25,000 gallons per year. The math is straightforward. 1 inch of rain on 1,000 square feet of roof yields approximately 600 gallons. A standard 2,500-gallon polyethylene tank elevated on a 10-foot platform delivers roughly 4.3 psi, enough for gravity-fed drip irrigation and low-pressure tap fixtures. For household pressure, add a second-story tank or a hillside installation. Costs: gutters and first flush diverters, $100 to $300. A 2,500-gallon tank runs $600 to $1,000. Platform construction, $200 to $500 in lumber or concrete block. What most people overlook, this system stacks with your garden, your livestock watering, your emergency reserve, all simultaneously. One collection surface, multiple distribution points. Overflow feed swales that recharge your well. You're not just collecting water, you're managing an entire site hydrology. Here's what changes the entire calculation. The systems we've covered so far require no ongoing fuel, no replacement parts on an annual cycle, and no specialized knowledge to repair. The next 5 systems add redundancy, depth, and capabilities that make a complete off-grid water supply possible on almost any property, even one without a stream or a spring. Number 4, the hand-dug well with rope pump. A drilled well with a submersible electric pump is a $5,000 to $15,000 installation dependent on grid electricity and a pump with a 10 to 15-year lifespan. When the pump fails, you have no water. When the grid fails, you have no water. That's not infrastructure. That's a vulnerability wearing a utility's clothes. A hand-dug well reaching a shallow water table paired with a rope pump still gives you water access that works regardless of grid status, pump availability, or service contracts. Rope pumps, also called Nicaragua pumps, were developed in Central America in the 1980s for exactly this purpose. Durable, simple, repairable, with locally available materials. The mechanism is a continuous loop of rope with small pistons run through a vertical pipe and turned by a hand crank or foot pedal. Flow rates of 5 to 15 gallons per minute are achievable. Hand-dug wells are viable where the water table is within 30 feet of the surface, which describes much of the eastern United States, the Gulf Coast, and major river valleys. Digging requires permits in most jurisdictions. Cost: $500 to $2,000 in materials, including concrete casing rings and a basic rope pump kit. Documented installations last 20-plus years with no professional maintenance. Here's the critical advantage. Every component of a rope pump can be fabricated or replaced locally. The rope, the pistons, the pipe, available at any hardware store. If something breaks, you fix it in an afternoon. That's the definition of resilient infrastructure. Number 5, the siphon system. The siphon is among the oldest and most reliable water-moving technologies in human history, and it requires nothing beyond elevation difference and a pipe. Water at a higher elevation will flow continuously through a pipe that crests above the source level and terminates at a lower point, as long as the pipe remains full and the outlet is lower than the inlet. That flow continues without any pump, indefinitely, powered entirely by gravity. Ancient Roman aqueducts used inverted siphon principles across valleys. Modern agricultural operations use siphon tubes to distribute irrigation water across entire fields at essentially zero cost. On your property, a siphon can move water from an elevated pond or tank to a lower garden, livestock trough, or secondary storage, passively, continuously. Setup cost is as low as $50 to $200 for a food-grade polyethylene or PVC pipe run. The pipe must be primed initially, filled with water to start the flow. For permanent installations, a vacuum primer valve makes priming automatic. For long runs with significant elevation change, a large diameter pipe prevents flow resistance from limiting volume. Here's what most people don't know. A siphon can operate under a hill. Water doesn't know it has to go over terrain. It follows pressure differential. You can route water through a buried siphon pipe over a ridge up to 25 feet above the source water level, as long as the outlet on the far side is lower than the source. This opens layouts that would otherwise require a pump. Most people think water independence requires expensive drilling or complex solar arrays. They're wrong. Every system we've covered today costs less than 2 years of the average American's utility bill and lasts 10 times longer. The next 3 systems address filtration, storage, and the one scenario most people forget to plan for: drought. Every system in this video operates on gravity, pressure differential, or kinetic energy conversion. These aren't clever tricks. They're the forces that moved water in human settlements for 6,000 years before electric pumps were invented in 1859. Electric pumps are a 165-year experiment. Gravity is permanent. The average American household spends $1,100 per year on water and sewer. Over a 30-year mortgage, that's $33,000, and rising as infrastructure deteriorates. Compare that to a complete gravity-fed independent system costing $3,000 to $8,000 in materials with a 30 to 50-year service life. The math isn't close. These systems outlast modern alternatives because they have no single point of failure requiring external supply chains. A sealed electric pump fails, you replace it. A ram pump's wear part is a rubber disc costing a few dollars. You replace it yourself. That's repairability, the defining trait of resilient infrastructure. Combining multiple systems also creates redundancy. A single well can go dry. A single spring can fluctuate. But a cistern fed by rainwater, a ram pump, and a spring box draws from independent sources. When one weakens, others compensate. Centralized systems are efficient when everything works and catastrophic when something fails. Distributed systems are less efficient but dramatically more resilient when it matters. Stored elevation is stored energy. Every gallon in a tank above your home is a gallon that moves under pressure without any input. When you position storage on high ground, you convert your site's topography into permanent hydraulic infrastructure. Gravity doesn't depreciate. It works during a blackout as reliably as any normal day. The water utility needs you to believe clean. Reliable water requires their infrastructure, chemicals, service contracts, and monthly payment. Every system here proves otherwise, practically, measurably, and verifiably. You are not obligated to rent access to a resource that falls from the sky, flows through bedrock, and moves downhill by physical law. The only thing between you and water independence is the decision to build infrastructure instead of paying for someone else's. This isn't a weekend project. A full system is a multi-year build. Assessment first, then one system at a time, layering redundancy as resources allow. But the first step is simple. This week, walk your property and identify your highest elevation point relative to your home or garden. That point is your future storage location. If you have a stream, find the section with the most vertical drop. That's your ram pump site. If you have no stream, measure your roof area and calculate your rainfall catchment potential. That number, likely more than 20,000 gallons per year, is water you're currently letting go unused. You don't need all 8 systems to start. You need one. Build it, understand it, use it, then build the next. In 5 years, you won't have a water bill. You'll have infrastructure. And when the grid goes down, when the next boil water notice comes, when the bill increases again, it won't be your problem because you opted out. You own your water. That's not a survival strategy. That's self-reliance.